Hello everybody. So excited to start Force and Motion with you guys. This is our next unit. So let's go ahead and dive in and get started and get our first video done. Alright, so the first thing, let's just talk about motion, what it is, and some definitions of some things we might need to know in regards to motion. So when an object changes position with respect to a frame of reference, the object is in motion. And the reason we have respect to a frame of reference there is because you have to have something that's stationary to know if the object is in motion. You guys have seen this on TV when people are driving in a car, like on a sitcom, but you know they're really not moving, but the screen behind them is moving. So if we want to know if something is truly in motion, then we have to have something behind it or next to it stationary so that we can see that it's in motion. Now, distance is the measure of the path taken. You know, if I want to talk about how far is it from my house to the school, then that would be the distance I am from the school, and it measures the path I take to school. Displacement is when we change an object's position. So let's talk about the difference between distance and displacement. All right, look at this ball field. The distance from home plate to first base is 90 feet. The displacement of the runner is also 90 feet. This is the distance, the measurement of the path taken, and this is almost also how much you changed that person's position. Now let's look at a different picture. Here, the runner goes from home to first and first to second. So the distance they ran was 180 feet, but their displacement is only 127 feet because displacement is always changing the position from where they originally were. So we would just measure the starting point to their ending point, and that would be displacement. All right, now when we talk about distance, talk about displacement, then speed and velocity come into play, because when I talk about how long or how far away school is from me, then we start thinking about, well, how fast does she drive going to school and things like that. So speed tells us how fast an object moves. Velocity tells us the speed, so velocity tells us how fast something moves and the direction it's moving. So let's say that you're driving to Atlanta. Your speed would tell you that you're driving 75 miles per hour. The velocity would say you're driving 75 miles per hour north, right? Because Atlanta is north of us. When you're calculating the number for speed and velocity, the number is always going to be the same, right? Because velocity tells us how fast an object's moving, so that's going to be the same thing as speed. The only thing different from velocity and speed is that with velocity we add the direction the object is going, and sometimes it's not north, south, east, and west. Sometimes it's just down the hill or towards their house. Like, it just gives direction on what's going on. Now let's talk about calculating speed and velocity. Our formula, you will either see velocity equals distance over time or speed equals distance over time. Either one of those can be used, okay? So don't get confused when you see velocity or speed. Either one of them can be used because the number is going to be the same. Now I put V equals D over T because those are the letters that we will use to shorten the words so that we don't have to always write out the whole word. Now, if you have ever used the circle or the triangle method for calculating, then you'll already be familiar with this. And we'll go over this in class also, but the circle method is, if you'll notice up here, distance is over time in the formula. So distance has to be over time in the circle. And then whatever box is left over is what you put, what's on the left side of the equal sign. So what this does is this allows you to rearrange formulas without doing it algebraically. Since distance is over velocity, if we want to find time, we would cover up the time word, and then we would know that distance is divided by velocity. If we need to find distance, we would cover up distance in the circle, cover it with your fingers, and that would show us that velocity is next to time, so we would want to multiply those numbers. And like I said, we're going to go over this in class, but I just wanted to kind of talk about this circle. And I left something off this slide. I'm so sorry. Your units for speed and velocity is meters per second. So it's meters per second for that blank. I'm sorry I left that off. Now, let's do some practice. So what I would like you guys to do is I would like you to watch my first problem. We're going to do it together. Then I want you to pause the video and do the second one on your own before checking your answer. Okay? So sorry about that. I keep clicking. So now let's go to doing these problems. So number 1, calculate the speed of a dog running through a field. What is his speed if he is covering 23.7 meters in 54 seconds? Now, first of all, I want you to know that there are some things that you need to include when you're doing math. So over to the left side of your notes, I want you to write steps to include. And the first step that you need to include is writing your variables. The second thing you need to include is writing your formula with letters. Write your formula letters. I know this is messy. I'm sorry. I don't use this very much, so you're going to get messy writing. The third thing that we want to do is write our formula with numbers. And the fourth thing that we want to do is we want to solve with the units. You always want to make sure you have your units on your answer. Whenever we do a calculation problem, I want you to do these 4 steps. I know some of you are groaning right now because you don't want to write all of this out. It's not, I promise you, it goes really quickly, but it's really important that you do all 4 steps because then we can easily see where your answers are, right? We can easily see, I'm sorry, not where your answers are, where your mistakes are. So if you just give me an answer and it's wrong, I don't know what you did wrong to be able to help you. Okay, so it's really important that we include all 4 of these steps, and most of the time you're not going to get credit for it if you don't show me all 4 steps. All right, so make sure you do that. So let's go ahead and do our first problem. So the first thing we need to do, and I'm going to label these 1, 2, 3, 4 just so that you can relate them back to the different steps I just asked you to list. So the first thing we need to do is write our variables. And our variables are the things we know and the things we're looking for. So when it says, what is his speed? That means we're looking for speed. So we're going to put S equals question mark. That's what we're looking for. And then it says he is covering 23.7 meters. Now, meters we should already know measures distance. So distance is going to equal the 23.7 meters, and we want to write that down. And the last thing it gives us is he does it in 54 seconds, which represents time because seconds measures time. So that's writing our variables down, and I'm sorry that S looks like another 5, so let me see if I can fix that. Now, the second step is writing the formula with letters. So let me go ahead and draw our circle down here that we had talked about. It's distance over time, and we have speed. So if I'm looking for speed, I want to cover up speed. I don't want to look at that. And so I'm going to put S equals, because that's what we're trying to find. And when I cover up the S, it shows me that I need to divide distance over time. So that's my formula in letters showing what I do. I know we wrote that above in our notes, but we're not always looking for speed. Sometimes we're looking for distance, sometimes we're looking for time, and so this formula will change. So that's our formula in letters. Now let's write our formula in numbers. And all you do to do that is replace the letters with numbers. So speed equals 23.7 meters divided by 54 seconds. Okay? And then we're going to solve with units. Now real quick, when you divide, you always put the number on top in your calculator first. Okay? You always put the number on top in your calculator first. So think about it like this. On top is number 1. Like when you're on top of the list for something, that means you're number 1. And number 1 things go in your calculator first. So you're going to put in 23.7 divided by 54 seconds. We want to solve with our units. And when you divide that, you get 0.44 meters per second, because our units for speed is meters per second. And if you'll notice in your problem we just did, m is divided by s, which makes our meters per second. Okay? Now I want you to pause the video and do all 4 steps, even if they're wrong. Even if you're not sure exactly what to do, I just want you to try. Okay? It's okay if you don't do everything perfectly right. But try number 2, writing all the 4 steps, and then we're going to check our answer. Okay, let's go ahead and check number 2, and let's see if you did your steps right. So you want to write your variables. It told us that the distance was 347 meters. Told us the time was 134 seconds. And it asked what is her speed. So our formula in letters, S equals D over T. Our formula in numbers, 347 meters divided by 134 seconds. And our speed is going to be 2.9 meters per second. And a rule of thumb, as far as, because you may have gotten an answer with a lot of numbers, always round to the second decimal place. That's just a good rule of thumb. Round to the second decimal place. And this is your answer. If you're not sure what you did wrong in class, make sure you ask me so that we can talk about it. Okay? Now I want you to do numbers 3 and 4 by yourself. Pause the video, do them, and then come back to check your answer. All right, for number 3, the ball's speed was 0.57 meters per second. The fish was 0.23 meters per second. So that means the fish was faster. Okay? For number 4, the answer is 3.4 meters per second southwest. 3.4 meters per second southwest. Now make sure, I want to see all 4 of your steps on these when I check your notes tomorrow. So make sure you have all 4 steps. And but if you didn't get them right, let me know and we'll go over those tomorrow in class. Okay? All right, we have one more thing to talk about in this video, and it's how to graph speed. And speed can be determined by the slope of a distance versus time graph. So if you have a graph that shows distance and time, you can actually calculate the speed by calculating the slope of a straight line. Time is plotted on the x-axis, and distance is usually plotted on the y-axis. So if you'll notice, if you learned about slope, it's usually change in y over change in x, right? Or rise over run. So all you have to do is pick a point on this line and do your rise over run, or your change in y over change in x. And so I'm going to show you what that looks like. So let's look at the red box first over here on the left. We go up, and that's 8. And if you'll notice, your y-axis is distance. So to this, if we go to this point, that is 8 meters. So we go ahead and put 8 over here where our distance is. And our x, the change in x, is 4, right? Is 4. And on this axis, it represents time. So over here in our formula, it's 4 seconds. When you say 8 divided by 4, it's 2 meters per second. And that tells us the speed of this line. Now, if you'll notice up here, they've calculated 0, right? Because there's no change in y. So when you ever have a 0 on top of a division, it's always going to be a 0 answer, right? And then they've calculated the very last line in green as well. So you can actually use motion graphs, which is what this is called, to calculate the speed of something. Now, I've got this in your notes. So if we have a straight line on a distance versus time graph, it's important for you to recognize what's on the y-axis, what's on the x-axis, because any other graph doesn't show speed, only a distance versus time graph. So whatever 0 is, that's our starting place. So this blue line represents constant speed because the line is straight. If the line was curved, that would mean they were changing speed here and there. But this is a constant speed. You know, once they got to 20 meters per second, they stayed at 20 or whatever it is. And they're moving away from their starting point. Okay, let's look at the middle one. This is also showing constant speed because it's a straight line, but the object is moving back to the starting place. They're moving closer, coming back to where they started from, okay? And then the last one shows no speed. If you'll notice, it starts at a distance of about 8 meters. It stays at 8 meters. That's kind of like when I come to school, let's say that I'm 15 miles from my house, I stay here all day. So while I'm here at school, my distance from my house to here doesn't change, but I'm here for 8 hours. So this is where basically like someone's gotten somewhere and they've stayed there for a period of time. So when you have a horizontal line on a distance versus time graph, that means that the speed is 0 and that the object is not moving. All right, this is what I'd like you to do. I want you to summarize today for me, and I would like you to tweet a summary. So I think it's 140 characters. Maybe it's increased because I'm old and don't know these things. But I want you to tweet a summary. You can only use 120 characters, but I want you to summarize what you learned today in the video. I hope you have a great evening, and I'll see you in class.